Okay guys, so today I will be sharing with you guys the answers that my group and I have decided to come out with for set 7 in the topic of alkenes. So let's start with the first question, in which we are required to draw the treated butahexane structure and explain why the given name is incorrect according to IUPAC nomenclature, and we are supposed to give the correct name then. So the treated butahexane structure should be exactly like the picture attached in this PowerPoint slide. So on your left side is what you would have if you were to draw your treated butahexane in skeletal structure, and on your right side is what you will have if you were to draw your treated butahexane in expanded structure. So the given name is incorrect because of the position of the substituent. As we can see by using the expanded structure to have a clearer picture, we are able to give a specific name of the structure instead of using treated butahexane, which is very general. We are able to name the structure now to 3-ethyl 2,2-dimethylhexane by obeying the IUPAC nomenclature rules. Next, propane is given as the linear alkane and 2,3-dimethylpropane is given as the branching alkane. So I have also attached the structure for propane and also 2,3-dimethylpropane together with the molecular weight. So as we know, the factors affecting the boiling point of alkane will be the molecular weight as well as the molecular shape. As you can see here, propane's weight is 44 gram per mole, and the 2,3-dimethylpropane weight is 72 gram per mole. So obviously 2,3-dimethylpropane will have a higher boiling point because of greater molecular weight. So in this case, my explanation will be propane has lower boiling point compared to 2,3-dimethylpropane. Even though it is arranged in linear chain, it has lower molecular weight compared to 2,3-dimethylpropane. Therefore, propane has lesser total surface area in contact and hence weaker van der Waals forces. Therefore, the boiling point is much lower compared to 2,3-dimethylpropane. You guys are also able to explain it vice versa, in which you state the factors that causes the 2,3-dimethylpropane to have a higher boiling point, and then you compare it with the propane because the question is asking us on which alkane from this given two have a lower boiling point. Okay, next, the Roman 2 question. Propane are soluble in benzene and we are required to explain. So as we know, alkane will only react with the non-polar solvent because alkane itself is a non-polar molecule, so it will not be able to react with the polar solvents such as water because they will not be able to form the hydrogen bond with water molecules, and hence they will only react with non-polar solvent such as benzene because they as in alkene will be able to form intermolecular van der Waals forces with the non-polar solvent. Alright, so this is the solubility part of alkene, in case any of you are wondering which part of it. So moving on, we are required to state two main product form when an alkane is combusted in slightly limited supply of oxygen. Sorry about the misspelling. It is supposed to be in slightly limited supply of oxygen. So two main product that you will have when there is a limited supply of oxygen will be our carbon monoxide as well as water. Okay, question 2b. Monochlorination of ethane in the presence of ultraviolet chloroethane and hydrogen chloride. So the first question, we are required to come up with the chemical equation of reaction. When we talk about alkane, we know one of the common reaction that alkane will go through is definitely free radical substitution. So this is supposed to be our chemical equation for the given statement. That will be our ethane as well as our hydrogen chloride with the presence of UV and our product. So Roman 2, they want us to show the mechanism of reaction in termination step. So we know we have 3 steps in termination. Termination step is basically when you stop the reaction, when you stop all of the free radical reaction. So you combine the common free radical together in order for us to stop the process. So the first one, we have the chlorine free radical. So you react with them to get you react them together in order for us to stop them. Okay, so for Roman 2 is when our basic structure but in free radical. So you previously we have ethane, so right now we are going to stop the free radical of the ethane. And then on the third step, yes, I was waiting for that actually. So on the third step, we stop the free radical. So previously in step 1, step 2, you should have the free radical at the chlorine and then at the ethane. So right now we have already done the 2 common free radical termination step. So right now we are going to stop the free radical but different type. So that will be our ethane and also our chlorine, and that is our 3 steps in termination. And Roman 3 question, we are required to name the new alkane formed in our previous drawing. Basically in our first question, let me share with you. Okay, we are supposed to name the product. So our product will be chloroethane.